Hey there, this is Workbench from Workbench Quagmire. It is day 15 of our free code camp Python certification in about 100-ish days. Today we're going to cover enumerate zip functions, list comprehensions, and lambda functions. So let's jump right in. So what are enumerate and zip functions and how do they work? So in a previous lesson, you learned how to work with the for loop, which is used to repeat a block of code a set number of times. Here's an example of a for loop to print each language from language list to console. So our languages, Spanish, English, Russian, Chinese. For language in languages, we just print the language. So the output would be English, Spanish, English, Russian, and Chinese, each on their own line. What do you want to keep track of? The index of each. But what if you want to keep track of the index of each element? Well, one option is to create an index variable and increment it by 1 for each iteration of the loop like this. So you have now a list of languages and an index integer variable assigned to 0. 0 is assigned to index. And then you would go through there and increment index each time. And that way you would have that. So while that works, an easier way to do that is by using enumerate function. The enumerate function keeps track of the index for an iterable, returns an enumerate object. If we pass the languages list to the enumerate function and convert its returned value into a list with the list function, it looks like this. So we have our languages, list enumerate languages, and so the enumerate basically creates this tuple of index and language. And then of course we use the list function here to add these brackets, which makes it a list of tuples. And the tuples have a integer and a string in each one. Each entry in the enumerate object, now a list, is a tuple containing count followed by a value from the iterable passed to the enumerate function. Now let's factor the example from earlier to use the enumerate function. So again, we have languages for index language and enumerate. So when you do this index language thing here, you're basically saying, give me the tuple that enumerate creates, and then I have the first or the 0th item in that tuple and the 1th item in that tuple. And so now we print index, the index of each tuple, and the language in each tuple. So we unpack the count and value for each tuple to enumerate in the enumerate object into variables named index and language, respectively. Finally, both of those variables are used in an F string that is printed to the console in each iteration of the loop. So there's our output. This removes the need to manually updating an index variable. The enumerate function also accepts an optional start argument that specifies the starting value for the count. If the argument is omitted, then the count will begin at 0. Here's an example using the optional start argument. So you can see here we use the optional start. So down here we get index 1 instead of index 0, which is handy if you're trying to create some sort of user understandable output, because most people don't think the first item of a list is the 0th item of a list. Only programmers think that. So far we've only been iterating over a list, but what if we need to iterate over multiple iterables in parallel? Well, you can use the zip function for that, which combines lists into a pair of elements and returns the iterator of tuples. So if we pass a list of developers and IDs to the, I guess that's IDs, to the zip function and convert its return value into a list with the list function, here's what it looks like. So we have our list of developers, our list of IDs. So we zip these together to create tuples, which we then feed into our list function. So, and here's an example using zip function with a for loop to iterate over developers and IDs. So we have a name and ID, for name and ID in zip. And so we're taking these two lists and we're putting them together. And then we're printing out name and ID. So in this example, zip combines the two lists into a pair of elements and returns an iterator of tuples. The for loop then unpacks each tuple into name and ID. Finally, for each print statement, we are printing name and ID for the IDs and developers list, respectively. Here's what it looks like in the console. So the enumerate and zip functions are very powerful, and when combined with loops, can make your code much more concise. So what does enumerate function do? It is used to print the memory address for each element in a list? Nope. It is used to create tuples and sets from lists and return an enumerate object? No. It is used to keep track of the index of an iterable and return an enumerate object? Yes. It is used to speed up the performance for your Python application? No. So, second question, which of the following optional arguments in the enumerate function specifies the starting value for the count? Set? No. Position? No. Start? Yes. Count? Nope. And what does the zip function do? It is used to iterate over multiple iterables in parallel. It is used to create a zip file. Zip files? No. It is used to break out of a nested loop? No. It is used to create an iterable that saves memory starting from a list. I think it's the first one here. So let's see. There we go. All right. List comprehensions. What are list comprehensions and what are some useful functions to work with lists? So for the past few lessons, we've been getting comfortable working with loops like this. So we have a list of even numbers that's empty. We have a for loop where we're saying the number in range 21. So we know, remember that range, the 21 is non-inclusive. So we're going from 0 to 20. And if the number, this is the modulus argument, so what's the remainder if we divide each number by 2? If it's 0, which would indicate it's even, then we execute this code block, even numbers, dot append num. So that just adds whatever number we're on to this even numbers list. And then we print the list of even numbers. This example creates an empty list called even numbers, like I said, and loops through a sequence of between 0 and 20. Inside the loop, there's a conditional that checks if the current number has a remainder of 0 when divided by 2. This is used to determine if the number is even. If the condition is true, then the current number is appended to the end of the even numbers list. Finally, we print the even numbers list to the console. While the code works, there's a more concise way to write this that uses list comprehension instead. List comprehension allows you to create a new list in a single line by combining a loop and conditional directly within the square brackets. This makes the code shorter and often easier to read. Here is the refactored example from earlier. So we have even numbers is assigned to these brackets. This means we're going to assign it a list. Num for num in range. So this is our for number in num range. So we're going to return the number for each of this if the number has a remainder of 0. And then we just print the even numbers. So it's one line versus 1, 2, 3, 4. So you remove 4 lines there. I think when you're starting out, this can be a little bit confusing. I remember when I first saw them, I was like, I don't understand what's going on here. But once you learn them, understand them, you can read these sort of things and be like, oh, I can see how this could be useful. I don't have to write 3 lines of code. I can just create this list very easily with 1 line. In this refactored example, the even numbers list is created using a single line of code. The list comprehension loops through the numbers from 0 to 20 and includes only those that are divisible by 2. The approach is more compact and eliminates the need for a separate loop and conditional block. Let's take a look at another example so we can better understand how list comprehensions work. So this example, numbers 1 to 5. And here, we're going to return a tuple if the number is even, else it's going to return odd for numbers in numbers. So basically, it's going to look at each number. If it's even, then we'll return this tuple with the number and even. Otherwise, it has to be odd. Therefore, we return this tuple with the number and the string odd. And then we print the results. So in this example, we have a list of numbers. You want to create a new list of tuples indicating which numbers are even or odd. In the first part of the list comprehension, we use an if statement to check if the number is evenly divisible by 2. If so, then the result is a tuple of that number followed by the word even. Otherwise, the result is a tuple with the number followed by the word odd. So here is what the results look like. It's a list with all the tuples, 1 for each number in the list. Another way to create a list starting from an existing iterable is the filter function. Here's an example of a way to create a new list of just words longer than 4 characters. So we have this list of words, and so we're going to define as longer. We're going to give it a word. We're going to return the length of that word and determine if it's greater than 4. And so this is going to return true or false, a Boolean. Now we take that function and that becomes our filter function. So long words equals a list based on the filter using the function is long word as our filter and words as our input to that filter. So then we just print long words. So we would get 3 back, mountain, river, and cloud. The filter function is used to select elements from an iterable. And basically what this is doing is, and like I said, it was returning a Boolean. So every time a word goes in, it says, hey, if it's true, so the filter is looking for true or false. It's looking for a Boolean. That's important. And then it adds that word to the list if it is true. That function returns true. So the filter function is used to select elements from an iterable that meet a specific condition. The filter function accepts a function and an iterable for its arguments. In this example, we're passing in is long word function into filter function to check if the current word count is greater than 4. All words that have a character count greater than 4 are added into the new list and assigned to the long words variable. Aside from filter functions, there's also a few more functions that are helpful when working with lists. Another function to be aware of is the map function, which takes an iterable and applies it a function to each of its elements. There's an example of a map function to convert a list of temperatures from Celsius to Fahrenheit. So this one is doing a conversion. It's changing something. The other one was evaluating the argument that was assigned each of those items in the list to return a Boolean and say, hey, should this be included in the new list or not? Now this one's going to take a list and convert it to a new value. So you see here our to Fahrenheit function takes a temperature in Celsius and returns the temp times 9 divided by 5 plus 32. And then we have this Fahrenheit that we're going to assign a list to. and we're going to determine that list by putting the list of temperatures in through this mapping function using to Fahrenheit to do our conversion. So, and then it prints our values down here. So just like filter, function map accepts a function and an iterable for its arguments. The to Fahrenheit function takes the temperature and converts it to Celsius, from Celsius to Fahrenheit. The last function we will look at is the sum function. This function is used to get the sum from an iterable like a list or tuple. And here's an example using the sum function. So we have numbers, we have a list of numbers. We take that list and just use that as the argument to our sum function to get our total, prints our total. You could also pass in an optional start argument, which sets the very initial value for the summation. So here's an updated example using the start argument. So we have the same numbers here that would add up to 50. But now we're saying, hey, we want to start with 10 and then add the 50 to it, and that gives us 6. You could also use to choose the start argument as a keyword argument like this instead. So where you'd say start equals 10. That's the same thing. Both versions will produce the same result, but the keyword argument is a little more explicit. List comprehensions, as well as other functions like map, filter, sum, might seem a little bit confusing at first, but with enough practice and time, you'll start to feel more comfortable using them in your Python programming. Yep, that's how I felt. Initially, I was like, what is this stuff? What is this list comprehension thing? I don't even know how to write one. And now when I see one, I go, oh, that's nice. It's a nice way to take a simple loop that has a basic conditional and converting into a list. You don't want to do complex things. Something with a bunch of elifs are not really a good idea for a list comprehension. So, which is the following correct way to use list comprehensions? While, for, no, we didn't cover that. Num for num in range 21, if num, that's exactly what we covered. Num for num, that's not sure what that would give us, but it doesn't look like it gives us much. For num in range, if num, no, because you have to have that num at the beginning. This is what's going to get returned. So our answer is the second choice. Which of the following functions takes an iterable and applies a function to each of its elements? Let's see. View, memory view, never heard of it. Map, yep, we covered that. Max, no. Min, no. Has to be map. What is printed to the console? So we have a list of numbers. This is the exact same example, sum. So it's going to get 20 or 60, sorry. 5, 10, 15, 30, plus 20, plus 10, 60. Yay. Got one more section here. So what are lambda functions and how do they work? This is another thing that can be a bit confusing, but once you learn how to use them and understand the use case, it's really helpful. So throughout the previous lesson, you have been used to defining functions by using the def keyword. So define, square, number, return number to the power of 2, print the square of 4, and give you 16. But it comes to working with high order functions like map and filter, you can use an anonymous inline function. This is where lambda functions come in. Here is what square function looks like once refactored into a lambda function. So you have to start with the lambda keyword. And you say, okay, well, I'm going to give it this number, not return. I'm going to give it a number, and that number is going to be evaluated against this expression. So as mentioned earlier, lambda functions are anonymous, so we don't name them. We don't say squares equals lambda, that was very confusing to me in the beginning. I kept trying to assign them to variables and stuff, and that's not what they're used for. So this is where the use case comes in. So if the function no longer has the name square associated with it, lambda functions are great when you need to use them in higher order functions like this. So say, well, I want a list of even numbers from my numbers list. And here we go using the filter again. Remember, it's going to return true or false. And then if it's true, it's going to return this number. So our lambda function, we don't have to define the function separately. We can just say we're going to give it an x from numbers, and then we're going to evaluate it against this expression. If the remainder of x modulus 2 is 0, true, then we'll return that number. Otherwise, it will not get returned. So it'll be false, and the number won't be included, basically. So this is the output. In this example, we have a list of numbers and want to create a new list of even numbers. So we pass in a lambda function as one of the arguments to the filters function to get a new list containing the numbers 2 and 4. When working with lambda functions, it's important to be aware of best practices. For example, it's not good practice to assign lambda functions to a variable like this. Yep, did that. Don't do it. It's not the right way to do it. You don't want to say, this lambda function is assigned to square and then use that. This defeats the purpose of anonymous functions. In this case, you should use a regular function like this. So if you want to define the function, then you do that. Also, you should avoid creating lambda functions that are difficult to read or unnecessarily complicated. Again, these are for simple functions. If you need to go through a list and figure out if the first character of the string of each item in the list has a string with the first character L, this would be a good way to use it. But you don't want to use these if, else, or elif, or any of this. We don't want to have these big, long, complicated things. So while the function runs fine, it produces a correct result of 14. It is not easy to read or look at. In this case, it would be better to create a separate function with an if-else statement and then call that function. So you'd create this more easier to read non-anonymous function, like a regular function, and then use that to calculate our expression. Both regular functions and lambda functions have their use case in Python programs. If you are dealing with a single inline expressions, I think it should be if you're dealing with a single inline expression, then you might consider using lambda functions. Otherwise, using a regular function would be the way to go. So which is following is the best use case for a lambda function? Defining a function with multiple lines and conditional logic? Nope. Creating a reusable function across multiple modules? Nope. You're going to use it once. Writing a small function for use inside of map or filter? That's a good use. Creating a function with a descriptive name for clarity. We don't name our lambda functions. They are anonymous. So there we go. Option 3. Why is it generally considered bad practice to assign a lambda function to a variable? It results in a syntax error. It does not. It defeats the purpose of using an anonymous function. That's true. Lambda functions are slower than regular functions. That's not true as far as I know. Python's does not allow this. It does, actually. So option 2 defeats the purpose. And what's the primary disadvantage of using complex lambda functions like the one shown below? It makes the code more readable. Not true. It could lead to unexpected behavior due to ambiguity. It's harder to understand and maintain. That's true. And it requires too many resources to execute. That's not true. So there we go. We've completed working with loops and sequences. So this has been day 15 of our 100-ish days of the Free Code Camp Python certification. Let's take a preview look here. So completed that. We're probably going to do a workshop. So got a 19-step workshop tomorrow. Build a pen extractor. I have no idea what that could possibly even be. That'll probably take a day. We'll probably take a day to do this. And then we don't do the reviews and quizzes. That's for you to do on your own. So those are the next 2 items on our list, or next 3. Build a pin extractor, our next 2, and then build a pattern generator. And then we'll be on to dictionaries and sets. Dictionaries are very powerful. Sets are kind of tricky. There's really good reasons to use them, and I don't often think of sets as a solution to certain issues, certain problems. So we talk about that when we get there. So thank you for watching the video. Don't forget to like and subscribe. Leave a comment. Let me know what you like, what you didn't like, and I'll see you tomorrow.